Here is for you, .NET developers and people interested in .NET development for IoT. The .NET IoT library is something you will want to leverage to connect sensors and work with sensors from .NET code. And Laurent is here to tell us everything about .NET IoT and how to use it and why he would want to use it. And that's today on the IoT Show. Hi everyone, thanks for watching the IoT Show. I'm Olivier, your host, and today it's an episode for .NET developers and others. It's an introduction to .NET IoT, and for that we have Laurent who's back on the show. Laurent, how are you?
Hey Olivier, I'm very well. What about you?
I'm great here in Seattle, and a bit rainy, but that's to be expected over here. Where are you calling from?
I'm coming from France. Actually, I'm French, as you may guess with my accent. We can even do this call in French together, but I guess like for the audience, that may be a bit boring, right? So
yeah, we could. And anyways, there's going to be captioning and so on, so we could definitely switch.
Yeah,
let's not. So you came already on the show to talk about .NET Nano Framework. Your team is working on many different projects related to helping .NET developers get onto the IoT bandwagon. Tell me a bit more about this team for people who don't know you and what you're doing.
Yeah, so I'm working at Microsoft. I'm a principal software engineering manager, and I'm working on with customers, our largest customers, to do co-engineering. And I have a passion, and I am about IoT. So I'm one of the main contributors for .NET IoT and .NET Nano Framework. I've been presenting in this IoT show like a few times already on .NET Nano Framework and .NET IoT, by the way.
Cool. That's great. And we'll talk about the openness and the open source aspect of these projects in a bit. But before that, I would say for our audience, lots of people are in the embedded world working on devices using C, C++. So .NET seems to be a bit counterintuitive when it comes to IoT development, especially when it comes to the embedded part of the development. And so Nano Framework is a great technology that we cover somewhere else. But here, we're here to talk about .NET IoT. So tell me, what is .NET IoT and why does it even exist?
Yeah, so .NET IoT, as it says, it's for .NET developers to be able to build IoT solutions. And when we say IoT solutions, it's really more on the T side of the IoT, so the thing part. If we can switch to the screen, I can show you the repository that we have. It's called .NET IoT. And here what you will find is basically what we call bindings. So I can give you an example of those bindings here. This is just C# code to be able to access some of the devices. And one I will use in my example is the BMP280. It's temperature and barometric pressure sensor. So we'll use this one later on. And as you can see here, it's very much looks like C# because it's C#, right? But here you access directly to the hardware to be able to read temperature, humidity, and so on. So we have those great readmes with a lot of details, which explains you how you can connect those sensors, how you can use them. So this is really the aim. It's to be able to help developers to do those kind of IoT solution with .NET directly. And it's not just about those little sensors. We do have as well like bindings to be able to read the normal temperature of your PC, the process, etc. So you can even use that for this kind of usage.
Got it. So it could have been called .NET for sensors or something like that, right? Because it's really, as you were saying, it's really about the T side of things. .NET for IT itself. Absolutely. It's really about allowing .NET developers using familiar tools and technologies to access hardware on devices, right? That can run .NET.
Exactly. So anything that can run .NET can run .NET IoT. For example, a Raspberry Pi. I will use that one, Raspberry Pi 3, I think, in my demo. But you can run it as well on your normal Windows machine or Linux or Mac. You just need a way to get those little connections for the T part, and we'll cover that as well in a demo.
Yeah, because accessing the usual things that a embedded developer would need to know and access, the registers, the GPIOs, I2C, SPI, all these acronyms that lots of .NET developers might not even know about, are things that are required to access hardware with specific field buses, specific connectivity that is not USB, that is not provided by the OS by default. And this is what this library is about.
Yes, absolutely. And you still need to know a little bit things like if your sensor is an IoT, I2C sensor, or if it's SPI or whatever. But again, we help you. We give you like the simple schematic with very popular sensors, how you can do that for your Raspberry Pi. And we really try to make it very easy. Every single sensor has a samples directory as well, where you have multiple samples in this case, because it's a family of sensors or sometimes one sensor, so you can just directly jump into some code. I've prepared an example with the Raspberry Pi. So here we will use a BMP 280. So maybe I can show you the setup on the device.
Yep.
So we can.
And before you jump onto that, real quick. So you mentioned the fact that .NET IoT is usable and works on OSs and devices that will support full .NET, as in Windows and Linux builds and so on.
Yep.
Let's debunk the difference with .NET Nano Framework real quick.
Yes. Okay.
So that way people are not confused, and then we'll jump into that example that you have here.
Okay. So if we can switch to the device, I can show you the difference between both somehow. Okay. Here I have a Raspberry Pi. It's quite big. And here I have an ESP32. It's quite small, right? This is an MCU. This is a CPU base. So .NET Nano Framework, that's really for the very little things that run on a battery, for example. Raspberry Pi, you cannot run on a battery very long. So this is really where you have the main difference. And .NET Nano Framework, it's a subset of the full .NET. Obviously, you can do less things. Still, you can do a lot of things. You can connect to Azure. You can have a web server. You can connect to Wi-Fi. You can do a lot of things. And APIs between both are aligned. So you can really reuse, for example, this BMP sensor on .NET Nano Framework. And we had one episode about that previously. So I can encourage you to have a look at that.
Yeah, definitely. We'll point people to that. So in a nutshell, Nano Framework for microcontrollers, tiny version, does include access to the hardware, and also has an SDK for accessing to the cloud, right? Connecting to Azure IoT. And on the bigger side of things, big.NET, you add .NET IoT library to access the hardware, and eventually you have the device SDK, the C# one, for connecting to Azure IoT as well. So you do the same things on different sizes of devices, leveraging, the bigger framework on the bigger device, obviously.
Absolutely. It's absolutely that. And here, so I have a Raspberry Pi. I have these little sensors here, which is like my BMP sensor. I know it looks bigger when you read on the README, but it's actually this very little one. It's connected to my Raspberry Pi. Now I switch to the code.
Let's go.
I show you the code.
Go to your screen. Let's see a code.
And I will show you how to access it. So it's very much like the same code you've seen already in the README, because I just did like the copy paste. The only thing I had to set up is the bus I'm using. I just need to know that. The address of the sensor, there are only 2 addresses. So I need to know that. And then I set up my sensor. Then I will read the temperature, pressure, humidity, and I will even be able to try to get the altitude with some of the helpers. For that, this is running on my Windows machine. What I will do is I will compile the code for my Raspberry Pi directly on my Windows machine. So you just do a .NET publish -r Linux ARM, and what it will create is a single directory containing all what you need to just copy paste on the Raspberry Pi and run it there. So I'm French. I have .NET in French, so you can enjoy having the message is in French. But it will be very quick. It's just compiling my project. And once it will be done, we will be able to copy it on the Raspberry Pi. So to copy it on a Raspberry Pi, I will just use WinSCP. You can do that with script. You can do a share. You can do anything you'd like to. Here is just to show you the process. So first I build, then I compile. It's built in debug version, by the way. I copy everything. Then once the copy will be done, I will be able to go here on my Raspberry Pi and run the code. So I just have to wait the few seconds for it to be fully occupied. Yeah.
So you were saying, yes, you're using SCP, which is basically on top of SSH, right? So it's a way of establishing a connection that is secure in exchanging files. I like to use Samba server on my Pi as well to expose a shared folder on my network. That's another way of doing it, but you were mentioning different options there.
Yeah, so here I run the program. I do read all of that. What I will do now is I will connect my debug. So I will attach to a process.
Okay.
In Visual Studio, SSH, my Pi address, and I did it previously, but I can look at all the processes that are running on my Pi, and I can filter like to see my BMP running here. So what I will do before attaching I will just attach the process here. I will debug just the managed code, but I can debug as well native code. And I will place a breakpoint somewhere in my code. And obviously, that should stop me.
Nice.
Yeah.
Nice. Yeah, so you're developing on the Windows machine for the Raspberry Pi. You're leveraging features that are part of .NET, right, as an SDK.
Absolutely.
For doing this remote debugging. So that's a benefit of using .NET, which is all the tooling is already in there, and now you can debug code that uses the .NET IoT library for accessing temperature sensor and so on. So you don't have to understand, how in that case, that BMP sensor is working in terms of registers and so on. You just use a few APIs, I guess, right from the library.
Yes, absolutely. And you have the watcher. You can get the data. You can get the detailed data. You can really get everything you need in there, like in a full experience. On the Pi, you just have to install a few libs. It's very well documented on our repo as well. You install that, and you've seen you attach the process, you connect, and you are good to go.
Nice. So we're bringing the device development to .NET developers, right? Making it simpler for them to create an application. But .NET developers are building bigger things, right? So I think you have an example of, as a .NET developer, you might be familiar with ASP.NET and creating solutions to go beyond just having an LED turning on and off, because IoT is about not just the things, it's about also the internet. And as a matter of fact, the internet could be an application that is remote and allows you to manage these devices. Could be connectivity to the cloud platform like Azure IoT. So it's really about extending the store, and this is where .NET developer can help a lot because they know how to build cloud apps. They know how to build this kind of things. So tell me more about this other sample that you have here.
Yeah, so I have a sample. It's on my GitHub, so you'll find it very easily as well. It's a sprinkler system. So that's the one I'm running at home and in my family and with a lot of people. So basically, it's really like homemade. Those are electro valves. I've done the soldering. I've connected to my water pump. I'm using those nice relays. And this is basically how my setup looks like downstairs, where I've connected like 5 different sprinklers. Looking at how it looks like, it's like that. It's an ASP.NET application, very classical, I would say, but it's using .NET IoT, of course, to be able to manage the relays, a few more sensors and information like that. What I can do as well, and that's deployed using Azure IoT Hub, Azure IoT Edge. So it's deployed on my edge with Azure IoT. It's all connected, and I have as well a nice application that is a boat. So my bot can do a lot of things, including like asking me, giving me information on my bottle of wines, for example, and stuff like that. But I can as well ask, like, for example, create a program today for 7 minutes at 22 on sprinkler 3, and if I write correctly program,
hopefully no one is in front of it.
Yes, what we can check here is quickly the programs that are there. There is none.
Okay.
And we just click in there to my bot, asking him to do that. Obviously sleeping because I'm not using it. I mean, when I'm not using it, it's sleeping just to save a bit. It takes like a few seconds. It says like, oh, you're trained to do that. Let's refresh, and I have it in there.
Nice. Now you have a program that's been added to that specific sprinkler. And this application you developed with your .NET skills is something that you spread across your family, right? You basically basically have a family control of sprinkler systems developed there.
Yes, it's centralized, for example, for the logging and etc. So because it's secured. So I mean, it's really like an application deploy. I use Azure IoT Hub for that. So that I create one deployment and I just had to add like new device to the deployment. Everything is done fully automatically. I have the bot as well, so every new site has a new location. So you can see as well, like it says it gave me like the location. I have other location, so I can say in this location. The default one is mine because like obviously I'm doing the demos and the default. But yeah, that's about it.
Well done, Laurent. Do you want to come back to the GitHub repo for .NET IoT? Because I have a question for you, and eventually we can bring the link down there, github.com/.net/IoT. So what I wanted to ask you, there's a bunch of sensors out there, and these sensors, they are a variety of them, some more commonly used. The bindings that are available through the .NET IoT library, can you walk me through, the breadth of the types of sensors and which sensors specifically that you have in the library right now?
Sure. So we have analog digital converters. We have the opposite. We have some accelerometers. You see like a lot of different sensors, gas, barometers, altimeters, tons of thermometers, infrared, some gyroscopes, some compass. We even have specific Lego devices. I'm a big fan of Lego, so that had to be, in the repo. Motors, inertial units, magnetometer, and more and more and more. Okay. Some displays. Like really, that's a lot of sensors. We even have specialized like CAN bus libraries to start with, touch sensors, some specific wireless transceiver and receiver. So, I mean, as you can see, you really have a lot of choice. Even have some media libraries. And so that gives you the opportunity to really do a lot of things. Yeah, as well, like a few devices I like to highlight here, and I can show you some of the magic is developing on the Raspberry Pi. It's okay, but you would prefer to develop on your real Windows, Mac, or Linux machine, right? So for that, we do have a few possibilities. So let's bring back the devices because I want to show you like the various possibilities. The first one, for example, is this extender. It's an FT232H. There is as well another one that you have in the repo, FT4222. I can do a quick demo as well for this one. And we have here a simple Arduino plugged with a serial port to my device. And that will bring the missing GPIOs, SPI, and I2C support that you have on Windows. And if we switch back to the code, I will show you how that translates compared to my example. So that was my basic example. I just created my I2C device. Here, this is how you do with an Arduino. So you just create an Arduino board, you connect to it. All the rest of the code is exactly the same. So it's just one line that you change. And with an FT device, same thing. You just get your FT device, you create it, and you are good to go with that one. Fully transparent. Okay. And here you can debug. So I can, for example, set this very little project on, and I cannot do any IoT demo without a blinking LED. So I will just
that's the hello world of embedded devices for sure.
On this one. And if we can have a look as well of the device, again, you will see my device. It's this LED is on. As soon as I will hit the breakpoint, the LED will be switched off, as you can see in there, because obviously I changed the pin setup. I can do one more iteration that will switch the device on again, and I can continue like that. So I can really use my normal Windows machine, Mac or Linux to do the debug, to put this to create the device, and then deploy that on a Raspberry Pi or on another embedded device that does support.
Work in the comfort of Windows and full blown dev machine and then migrate with very little changes, as you were mentioning, onto an actual embedded device with the same code. Brilliant.
Absolutely. Yeah, absolutely.
Okay. Well, Laurent, that was really great. One more thing to mention. So let's bring that link below here. That's where you will find the .NET IoT library. And the other thing is there is a big community behind it, because you showed a list of bindings, but this is not just Microsoft people developing that. This is a community project. You do that sometimes and most of the time on your spare time. And you do welcome contributions from the outside. So people should definitely go there. How many contributors do you have already on this project?
We have more than 100 contributors on this project. So we have a couple of course, very high contributors, but some people just added one binding, and that's all perfect. Some people just corrected as well some bugs that they find in some bindings or added feature in some bindings. So we welcome any contribution. We do have as well two non-Microsoft people who are doing as well triage, and one has as well like the right to merge some code. So it's really community-driven effort. Even if I'm part of Microsoft, I'm not part of the .NET team at all. So I kind of consider as well like external for that one.
Nice. Great job, Laurent team and the community at large. I think this is a very promising framework that you have out there and library that you have out there. .NET IoT, .NET for sensors, for you to build IoT solutions as a .NET developer. Laurent, hope to see you. I know I will see you back soon on the IoT Show for more great discussions and demos about .NET development for IoT. So everyone, thanks for watching. Laurent, see you soon. Bye-bye.
Thanks, everyone. Bye.